Good evening everyone. How are you all? I think all of you might be in a bit disappointment mode, all of you. Those who are seriously preparing for MSET especially the students, those who are focusing on state entrance test. A disappointment news just now has been announced here. So at this moment, the only thing I can say you that here, take this postponement as a special opportunity to increase your conceptual levels, problem solving approaches and all those. Here, go in a positive way, definitely you will get the better rank because of this postponement. Don't go for disappointment here. Now coming back to our vectors class, where we have stopped yesterday, try to recollect here. Yesterday just I have focused on two particular points here. First thing is, what is the special case of vectors, in what way it is different from scalars. Just like it has magnitude, direction, and also this is freely moving in the space, which are called free vectors, that is why, and based on that we have discussed related points here. After that, how to express a vector. The second point yesterday what we have discussed is very important. Okay, all sensitive questions on rotation concept will be tested based on this only. Here in this, how do we express a vector? Generally we choose two different approaches. One is oblique base vectors and the second one is IJK system, unit orthonormal vectors taken along the directions of x, y, z axis, and we express any vector in terms of IJK. So that is rectangular system, and the first one is oblique system, where three non-coplanar vectors, base vectors, are chosen in non-perpendicular directions. Any three random, which are obviously non-perpendicular vectors. So we can express any vector in the space in linear combination with these three vectors, three base vectors, and that too that can be expressed in a unique way. If a vector is expressed as x a bar plus y b bar plus z c bar in terms of a bar, b bar, c bar base vectors, there is no other possible combination we have. Here this is the unique combination only we have. That point you have to remember. Now based on this, I have given you one more extension in this second point only, that is, if three vectors are coplanar, then there is no confusion at all. If three vectors are non-coplanar, then we can form a system with these three vectors, and in these systems we have right-handed system and left-handed system. I told you clearly how to recognize the type of system given. Okay, mathematically if you want, simply scalar triple product, find out box ABC. Positive will give you right-handed system, negative we get left-handed system. If it is 0, they are coplanar. Now physically here, to recognize in better way the right-handed and left-handed systems, I told you to take the classroom corner examples. Okay, if a problem is given on right-handed system, then start imagining with your opposite left corner. If a problem is given on left-handed system, you choose right side corner opposite to you and start comparing axis. Always y-axis vertical you take, x-axis your horizontal one, and your adjacent one is taken as z-axis, and start comparing the problem with incorporation with these three axes, so that problem will come very comfortably. Yesterday I told you in the last class very clearly about the rotation type of questions. Here, if axes are rotated through 90 degrees clockwise or anti-clockwise, left-handed, right-handed systems, various combinations whatever they test, you are supposed to get it comfortably by choosing your opposite corners. So I repeat once again, if a problem is given on left-handed system, you choose opposite right corner. If the problem is given on right-handed system, you choose your opposite left side corner. Choose the axis, and rest of the thing depending on the problem you follow as usual, answer will come. Without paper pen will get the result. Okay, not only that, in this rotation type of questions we can expect one more type of question. What is that? Here suppose a vector A bar has components p plus 1 and 1, it is a two-dimensional system. Suppose only two-dimensional system is taken. In this two-dimensional system, components of the vector are p plus 1 and 1. Now, the plane is rotated through an angle of some angle theta. It is not mentioned particularly how much is this angle, just an angle theta is given, maybe clockwise or anti-clockwise. After the rotation, suppose the components of that same vector have been changed as 2p comma 1, then what are the possible values of p? This type of questions also you can find. Just randomly I am choosing one of the previously tested question here for your better understanding. Here I am repeating the question once again. Here a vector a bar has components p plus 1 and 1 in two-dimensional system. If the coordinate system is rotated through an angle theta in clockwise direction or anti-clockwise also we can choose, then components have been changed as 2p comma 1, then what are the possible values of p? Here clockwise, anti-clockwise not mentioned, and the plane, it is only two-dimensional plane, there is no z axis. That is why here just try to recollect here, in the rotation process, before and after the rotation there is no change in the position of the vector, and there is no change in the magnitude of the vector also. That is why try to recollect the simple concept before and after rotation. Here in change of axis also, in geometry changes of axis, try to recollect in translation of axis or in rotation of axis what will be changed, coordinates will be changed, equations will be changed, but what will not be changed in rotation or translation of axis, the shapes will not be changed. If a triangle is taken after rotation of axis, it becomes a square, it is not possible. The area, the shape will never be changed in the translation and in the transformation of axis, maybe rotation or translation. Even the sizes, maybe area, maybe volume of three-dimensional figure, okay, if it is a line segment, length of that line segment will never be changed. If you remember that simple concept, here apply that point. Before and after rotation, there is no change in the length of the vector. That is why here simply equate the length of the vector here and try to recollect. If x a bar plus y b bar plus z c bar, or x I cap plus y j cap plus z k cap is a vector, then what will be its magnitude will come under root x square plus y square plus z square, distance from origin to the coordinates to the point whose coordinates are x, y, z. The distance, this OA bar, will give you under root this one, which is magnitude of that vector. Here applying this one, here before rotation p plus 1 whole square plus 1 under root, after rotation the magnitude 4p square plus 1 under root, equating both of them, squaring both sides, here 1 cancel, p plus 1 whole square, p plus 1 whole square equals to 4p square. Okay, just expanding this one, p square plus 2p plus 1 equals to 4p square. Okay, here otherwise we can take here only the result, p plus 1 equals to plus or minus 2p on taking square root both sides. Here we are getting then p plus 1 equals to 2p, p plus 1 equals to minus 2p. Simplifying, we get p, two different values will come. So this is another type of question based on this rotation concept. Yesterday I have given one question, today also I am giving one more question. So like this rotation concept, we can construct so many questions which will give you the better solutions by using yesterday's concept. That is why I am very particular about this point to be given as second point in this here. Now coming to third point in this, in the synopsis, which other point you have to focus, you have to concentrate. Simply this is about the section formulae. Okay, just like in two dimensional geometry, we have the same is extended to this vectors here. Suppose A and B are 2 points whose position vectors are A bar and B bar with respect to the origin. OA bar is A bar, OB bar is B bar. Somewhere here we have origin. So, this vector OB bar and this vector is OA bar. Now, suppose this AB is divided by another point C in some M/N ratio internally, then the position vector of this C will be OC bar equals to MB bar plus NA bar by M plus N. Like in Cartesian system we use the point which divides 2 points in the ratio M/N will be mx2 plus nx1 by M plus N. Similarly, y coordinate will be taken. In same way, we apply that result to what? This vectors also. So, if the point is dividing these two in the ratio M/N externally, we can get it as minus here MB bar minus NA bar by M minus N. So, very simple one. This section formula also is taken as one of the most important synopsis points in this chapter. What type of questions you can expect on this? Many questions we can expect. Different types of questions we can construct on this section formulae. Just randomly I will choose 2-3 points how can be tested, especially in mains level and advanced level also you can expect this type of section formula, because it requires some calculation, little bit lengthy comparing to other models. Okay. So, here if you go just little higher level test papers, for example, here just randomly choose a triangle. OAB is a triangle. Suppose OAB is a triangle in which the position vectors of A bar, A and B are respectively A bar and B bar. This is a triangle now. Now, in this, suppose C divides OA in the ratio 2:1, and here suppose D is the midpoint of OB, D is the midpoint of this OB, and suppose AD and BC are intersecting at a point P, then any question you may be tested in this, you may ask to find this BP is to PC ratio, the ratio in which point P divides B and C, or DP is to PA, this ratio DP is to PA ratio you may be asked, or you may ask the position vector of P, what is OP bar, position vector of P, etc. Any type of questions you may test, these are all based on section related formula. Just one simple result here, MB bar plus NA bar by M plus N internal or external with minus signs. Applying this type of problems can be solved very comfortably. Okay. Now, I will choose randomly 2-3 such different examples to make you clear about using this particular type of question solution methods. Here, just try to solve this type of problems. Before solving this problem, I will tell you one particular idea. Any type of this type of problems if you are given, luckily in this problem I have given one vertex as an origin. If it is given as some general triangle ABC, we can choose one of the vertices as origin immediately. Okay. Suppose triangle ABC given, then we can take A as origin, then we can get the solution in better way. Always try to get two position vectors in entire problem. In entire problem, whether it is given 4 vertices or 5 vertices or 2 vertices, 3 vertices, we always try to solve the problem by taking 2 vertices hardly maximum, then easy to get the result here. Now, step by step analyze in this problem what are given. Here position vector of A is A bar, position vector of B is B bar, OA bar is B bar. Now, find OA in what ratio 2 is 1. We can apply the formula B bar, this 2 A bar plus 1 into 0, 0, A plus 1 is 3. This is the position vector of C. I am applying section here. Not only so, this D bar will, it is given as one midpoint of origin, and so A bar will be by 2 section again. Here we are midpoint of this is what? B by 2. Now we are able to all vectors A bar, B bar, terms of A bar. So we are getting with only 2 position vector terms. Now the position vector of P, or maybe this ratio required. Now let us assume that P is giving BC in the ratio 1 is to lambda. Let's do one choices was okay. I am taking this ratio as 1 is lambda. BP is PC, taking it as 1 is here. A and PD, this ratio, AP PD ratio, taking it as some mu is to 1 or some L is to 1, choices was okay here. So I am taking this one mu here, AP mu is to 1, or you can take 1 is to mu, choices was I said. Yeah, 1 is to mu I am taking. Now this is 1 is to mu ratio and this is 1 is to lambda ratio. Now the position vector of P, OP bar equals to, apply section formula now. Section formula to what? First of all, apply for AD here, AD. So A is A bar and this is B bar by 2. Apply now this ratio, 1 is to mu ratio. So here 1 into B bar by 2 plus mu into A bar by plus 1. Position vector with respect to the 1 is to mu is written like this. In same way, vector of P in 1 to lambda section lambda bar plus bar, what is C bar? 2 bar plus A bar by lambda is 1. Okay. Vector can be expressed in unit way in this vector. A bar vector is of a B bar basis should be expressed in unit way. UA means A bar and B coefficients same to these vectors. So clearing the containing coefficients, it means they are option. Okay, it means we take equal, they are in portion here. That way, here clearing the corresponding coefficient is B bar coefficient 1 plus 1 by is equals to B bar coefficient lambda is 1, and here B bar coefficient mu by plus equals A bar coefficient 2 plus 1, getting 1. Now from this there are 2 unknown things lambda mu are here and 2 equations given, and all the comfortably will solve eliminating any one. Dividing both them, here dividing both of what are now if you divide mu plus 1 is 1 1 by 2 by mu, 1 by 2 mu equals to how much you are getting, lambda plus lambda plus cancel, lambda by 2 by 3 lambda by 2 to cancel here, simply here 1 by 2 how much getting 3 lambda is substituting this lambda value in terms of mu equation, we are getting the value of mu. Okay, eliminate mu values in this is lambda value. If you are getting the ratio, subtract this ratio. Okay, if you put lambda mu in this, that so every will come back in terms of B bar and B bar if you think lambda mu values. I told already this is a little bit collection required term that I requires just physics test. Okay, that's why I told you can expect the percents means and advanced level etc. So this is the way of in this section. Not only we can treat question if the fundamental idea take one if better clarity on this, I'll give you one more example. For example, suppose we extend to polygons also. Okay, suppose here I'm choosing polygon on font OAB pentagon is not what some conditions are defined pentagon. A is a defined in a way that OAB is parallel to C bar. Question to define this bar is parallel to C bar and OD bar is parallel to A bar is parallel to AB bar. And AEC, OA and CB ratios are 2:1 and OD is AB is 1. Like this with a computed ratio, just see here that is one OA bar C bar parallel, OD bar A bar parallel, ACB less ratio is 1, OD and A ratio is less is 3 is 1. Use these questions we will construct a pentagon. Okay, after that in that we will get doing with ratios combinations. Before completing this problem, complete this diagram in the form. A B is a pentagon such that randomly in origin OA our is first. Suppose this A giving as some A bar. Okay. and CB. So CB and OA are equal. Total OA ratio is 1. The length of this one. One more is that AB. AB and OD bar. These two also are given. AB bar also given. The AB bar length is 3 times OD bar. O is to A. But otherwise we change this here. Ratio. Saying the because I have drawn the diagram. We can write it like it also not show. OD and AB. This ratio is given as to 3. It is 1/3 of this AB bar. And of course, bar this will continue. It is there. So A, B, C, D is a this. So A, B, C, D position vectors are given as A bar, C bar respectively. OA bar, this is B bar, this is C bar, this is B bar. These are position vectors. Now, please construct this different substance. A bar is another and both are intersecting. Yes, what if we can find now the problem constructed here. Here that OC and AD are intersecting at P. Then find out one position vector P. First to P bar. Expect AP third one. This P is what? This ratio is what position with this we can consider. If you want to strip OC take the OB bar. OB and suppose AC are intersecting some at X, then what is position vector of X? Like this, different types of course you can construct. How it was constructed? There were people given in this, but basically and end the solutions just using function formula and clearing the corresponding coefficient. Base fix both sides together is this type of problems. And more I told you do to remember this always like that. How many position vectors will be different in the diagram? Finally, we have to convert everything in only vector terms. So in the entire here, you have to get into two. You choose different options. Here, just I am giving questions where you how to convert them for. Here, just now, C B bar, B bar, A bar are parallel. And C B length is one of. C is half OA. So C bar is half of A. OA is nothing but A bar. So twice CB bar we know A bar is nothing but OB minus OC. C is written as OB minus OC. A bar it equals to A. This is number 2. OD bar is 1 of AB bar. OD bar 1/3 of what? AB bar. A bar is nothing but OB bar minus OA bar. Give you 1/3 of B bar bar. So here 3D equals to B bar minus A bar. This is number 2. These two conditions given these two equations. Now use these two equations we can eliminate the unnecessary term. We can eliminate the unnecessary term. Finally, equation should only end with two terms only. AC or AD choices depending on difficulties. Suppose P here is point one is lambda. This ratio. Okay. So if it is the ratio is lambda, bar will be equal to right vector of this section from minus r is lambda into 0 divided lambda 1 equal to other one. This AD bar. This bar will be here AD bar. This one I am taking as 1 is to mu. This is mu. Okay. Applying this 1 to mu here, mu d bar 1 into r by mu is 1. Clearly now left is A bar is A bar D bar. That's what will you do here? Just here E bar. Here C bar you write in terms of A bar and B bar or not? C bar we write in terms of A bar and B bar. Now here D bar we can write in terms of A bar and B bar. So the next we do is here just observe 2 bar equals to 2 bar minus 2 bar C bar by lambda plus 1 equals to said A bar D bar can replace say by now when we are relation X and B bar into different ways. Student will impossible it is you just clear corresponding coefficients of A bar and B bar. Compare corresponding coefficients of A bar and B bar. B bar coefficient minus 1 by 2 plus 1 equals to here a coefficient 1 minus mu by 3 mu is 1. B bar 2 cell 1 by lambda plus 1 into here B bar coefficient by 3 times plus 1. Again dividing these two equations. Divide these two equations we get lambda relation. Shoot in any back we are getting result. Such complicated such problems so we can solve by using very simple concept idea. I am repeating the idea once again. Calculate and leave it. However it whatever it can be. You have to remember one thing. In such terms, express the relation only in AB or AC BD combinations. Only two way to output only terms. Second thing similar one in double like and apply. Apply corresponding coefficients and divide. Answer come in very comfortable way. Solving this okay. So I'm much more important particular section keeping in your point. So repeating depend on what 8-12 point. And more thing, I want to answer more important thing. Like the exams have been posted, we are getting enough. So that's instead of going in form, just being in a cash way. Here, I will go into this so complete great particular. Okay, let us first cool way we hear from So Tomorrow I will complete the pointers and we will some previous chapters. I will of this. Thank you. Tomorrow continue. Thank you.